and welcome to the revision and practice session on permutation and combination. The link for the practice sheet can be found in the description box below. Again, I am also assuming that we have gone through the basics of this topic, because here we are straight away going into questions and practicing questions, right? Though as we solve any of the questions, the ideas will repeat, and I mean while discussion also we will see the basics getting repeated over and over again. But it is recommended that you do try out the basics before doing the questions. So download the file, try out the questions, and then come back to the discussion. Just before starting, let's cover a few basic ideas very quickly, and this will also help with the questions. So let's say if I give you a story, very basic story, that there are 3 ways to go from A to B and 2 ways to go from B to C, and I ask you how many ways to go from A to C. This should be a very easy question, and your answer should be 6, right? Because this is the very foundation of what we are going to do. This product has come from the AND function, right? So, or this is a representation of the AND. Why? Because when you go from A to C, you will have to go from A to B and B to C. And this means 6 ways. And what do we mean by 6 ways? You will go this way or this way, right? There are 2 ways that I tried. I will go this way or this way, another 2 ways. I will go this way or I will go this way, another 2 ways. So I count it. If I did it manually also, I'll come to 6, right? And while counting, it should also be visible the structure. Why is this product happening? Because when I think of this path, I have 2 options, right? So for each of the first stretch of the journey, I have 2 options. I have 3 stretches of the journey. For each of them, I have 2 options. So overall, I have 6 options, right? Another quick example, just to elaborate the idea further. Let's say you have 3 shirts, right? You have 5 pants. How many ways can you dress, right? And again, so the basic idea would be dressing involves a shirt and a pant. So if I think of a table, if I say, okay, show me how will you dress. So you might set up a table like this. Shirt 1, pant 1, shirt 1, pant 2, shirt 1, pant 3, shirt 1, pant 4, shirt 1, pant 5, right? So I see for each shirt there are 5 options. So now if you can write the table for S2 also, S3 also, or you can notice a pattern and say my answer would be 3 into 5. Once I get this idea, extending it is fairly easy. If I say there are 3 shirts, 5 pants, and 2 ties, right? So what will this add to the question? There will be another 2, right? Why? Because for each of these ways, of 10 ways, you can have 2 options of the tie. Let's say the red tie or the blue tie, right? So where you had 10 ways, each 10 way will get split into 2 more ways, giving you 20 ways, right? So just to get the idea started, get the mind warmed up, and noticing this expression over and over again, right? Something into something into something. What if I said that tie is optional, right? What does that mean? You can wear a tie or you cannot wear a tie. So this is also to introduce the idea of or. So if while counting or analyzing you come across the word or in your logic, you must use plus, right? So let's say when no tie, if I don't go for a tie, then this becomes 3 into 5, right? If I go for the tie, it becomes 3 into 5 into 2. Tie, no tie or tie. I have covered everything, right? So this would be one way of doing it. This was just to introduce this plus symbol or the or method, right? So the product represents an and the plus represents an or, right? Another way of thinking of this would be 3 shirts, 5 pants and 3 ties, right? Because let me think of the 0 thing also as a tie only. So basically what that means is, for the tie position there are 3 possibilities, right? So this could have been another way of doing this. Answer would be the same or should be the same at least. And the point while doing this is also that for any question there are very many ways of getting to the answer, right? But this product thing remains the backbone, fundamentals of whatever we are going to do, right? So now let's try out question number 1. So question number 1, From city A to city B, there are 4 ways. From city B to city C, there are 3 ways. And what else is given? From city A to city C, there are directly also 2 ways. Okay. So, looks simple, but maybe there is some complication here, right? And then he says, how many ways to travel from A to C and come back. So again, pay attention to that and come back. And while coming back, don't take the path that you took. So for example, if you took this and this path, right? Call it stretch 1 and this is stretch 2, this is stretch 1, 1, this is stretch 2, 2. That means the first part of the first stretch and the second part of the second stretch, right? So if you take this path, you cannot take this path while coming, right? So this is the story, and this story is going to put some spanners in your direct easy logic, right? So first of all, you might have, the first part would be fairly easy. How many ways? 4. How many ways? 3. And how many ways I can see here? There are 2. So, and I know from here to here there's an and, right? Because I'll have to take both the paths. So 4 into 3, 12 ways. So this overall represents 12 ways, and there are 2 ways. So 12 and 2, 14. And while coming back, whatever path I took, I should not take that. So I might say my answer is 14. And while coming back, I cannot take one of the paths, and therefore 13. 14 into 13, right? However, that is not the answer, right? And why is that? So I'll have to think a little more carefully here. Why? Say if I take this path, right? This particular path while going. So while coming back, I will not be able to take this, right? So when I think of removing the number of paths, the subtraction only would be, okay, remove one path, right? But if I had, for example, taken this path, and while coming back, I cannot take this path, right? So if I look at, I had counted these as 12 possible ways. How? 4 into 3. But now if I look at the coming back scenario, there are only 2 ways remaining and 3 ways remaining, right? And that means there are only 6 ways remaining. So the gap is going from 12 to 6. So the logic that I had just used, that simply go from 14 to 13, is not going to work, right? Okay, so if that logic is not going to work, what to do? I move the paths up so that there is some calculation space, right? So I know what path I take creates a difference, right? So let me put a plus in between. That means let me create a or situation to make my life easy, right? Why? Because if he takes one of these paths, while coming back, it will simply be a subtraction of 1. There will not be too much of a problem. But if he takes one of these paths, there is going to be a different change in the story. So I can use the or to split the story, right? So now if I have already done an or, let me think of going. How many ways of going? If I think of this scenario, there are 2 ways of going, right? And while coming back, if I do not take one of these ways, how many ways will remain? I can take one of the remaining ways, or there are how many ways? There are 13 ways here. So while coming back, he will have 13 options. What scenario am I talking about? I have created an or. I am saying in the scenario, he takes one of these 2 paths, that means 2 possibilities. And while coming back, he will have 1 possibility out of these paths and 12 more possibilities out of these paths. So far, 2 into 13, right? Or this plus, he will take one of these scenarios, right? And how many possibilities for that? 12. But if he takes one of these scenarios while coming back, how many possibilities? 6, right? But there are these 2 possibilities also while coming back. So how many possibilities for coming back? 6 from this scenario and 2 from here. That means 12 into 8, right? So 2 into 13 is 26. 12 into 8 is 96. So 96 plus 26 should be your answer, right? And I hope the logic is also very clear to you. Why and what is the problem with 14 into 13? Though some of you might have tried it. In fact, even my first thought was how easy, okay, simply 14 into 13. But then I noticed the problem, right? So 96 plus 26, see if it's there in an option, would be 122. So it would be option A. So this is question number 1. Okay, question number 2 is about forming numbers. So let's quickly revise the idea also. So if I give you, let's say 1, 2 and 3 and 4, and I ask you how many 2-digit numbers can you form, right? So it should be easy. In your start, you will start in your head. You start thinking 12, 23, 13, 14, 43, 34, etc., etc., etc. Right? But if I say, okay, logically, what is happening for the first number? How many possibilities? 1, 2, 3, 4. So 4 ways, right? Because in the first number, you'll either put 1 or 2 or 3 or 4, and in the second possibility, again 4 ways, right? And this would be 4 ways if I can also make numbers like 1, 1. That means I can use 1 over and over again, right? But if this was not allowed, right, and I said you have only this 1 of 1 and 1 of 2 and 1 of 3 and 1 of 4 to use. So one of them you have already used. How many are remaining? 3 ways, right? And this would be an AND, 4 into 3. So how many 2-digit numbers can you form? You can form 12 2-digit numbers out of this, right? And this is without repetition. That means you can only use a digit once in the number, right? And if repetition was allowed, it would be very simply 4 into 4, right? So this is the core idea about forming numbers. The foundation remains the same. How many ways into how many ways and how many ways product, right? Only the story format is different. So now let's try out the question, and in the question obviously there will be something extra beyond this basic. So using the digits 1, 2, 3, 4, 5, 6, 7, a maximum of ones, that means remember no repetition, you cannot repeat. Find the number of 4-digit even numbers, right? So when you are thinking of even numbers, what you know is that the last digit can only be 2, 4 or 6, right? This is the property of an even number. You cannot have a 7 or a 3 or a 1 here, right? So let me start backwards, because I was just counting ways. For me it's not important if I go from left or right. How many possibilities? So I will have a 2 or a 4 or a 6 here. How many ways? 3 ways, right? Because 3 possibilities. Now once you have put that number there, he is simply saying how many 4-digit even numbers. Okay, that's it. So this is taken care of. How many numbers were there? 7. Out of those 7, one of them is gone. Either 2 or 4 or 6 I have already taken care of, right? So out of 7, how many numbers will remain? 6 numbers will remain, and that means now for this first number I have 6 possibilities or 6 possible ways. And then this should be easy. Again, out of 7 numbers, 2 are gone. So how many are remaining? 5. And how many are remaining? 4, right? You can do this manually. So overall there were 7 numbers. One of them went there in out of 3 possibilities, right? And if one number was gone, how many ways? 6 ways. And now 2 numbers are gone. How many ways? 5 ways. Or if you have gone through this basic sessions again, you very commonly know this pattern by now, right? So 6 into 5 into 4, 120 into 4 is 30 into 4 is 120 into 3 is 360, right? So this is part 1 of the question. Just looking at it, 2 of the options can be eliminated, but let me find out everything right now. And the second part of the question was, find the number of 4-digit numbers more than 5,000. And this time he's not saying even, he's just saying more than 5,000. Now if I think of more than 5,000, that means this digit cannot be 1 or 2 or 3 or 4, right? The first digit cannot be this, this or this. So it can be 5 or 6 or 7, because if you put a 5 here, any number that you form would be greater than 5,000. If you put a 7 here, any number formed here would be greater than 5,000. So 5, 6 and 7 you have to put there, that means 3 ways, right? Now the usual logic comes into play. There were 7 numbers, out of that 1 is gone. How many are remaining? 6 are remaining. How many are remaining? 5 are remaining. How many are remaining? 4 are remaining. So this is the same thing, 30 into 4, 120 into 3, 360. So once again, even for this question or this part of the question, answer once again is 360. Again, still a fairly straightforward question with very basic conditions, right? Question number 3 In the above question, that means the same as question 2, find the number of 4-digit even numbers greater than 5000 that can be formed. Even numbers greater than 5000, that means both the conditions are being applied. So let's start doing it. Let me think of even numbers. So there was 1, 2, 3, 4, 5, 6, 7, etc. Right? Think of even numbers. I can have 2, 4 or 6. So there are 3 possibilities. So far okay. But if I think of the first number now and I want greater than 5000, again 3 possibilities. Right? But think about it. What if the 6 comes here? Let's say out of these 3 possibilities you ended up with a 6. If that happens, is that 3 possibilities, 3 ways really true? Because out of 5, 6 and 7, 6 would be gone and you'd only be left with 2. However, if it is out of 2 or 4, then there is no problem, there would be 3. And when you face a situation like this, what should you do? You should split the story using an OR, right? So you have a 4-digit number. It will, let's say, either end with a 6. That means only one way I am considering. If that is the story, how many ways for the first digit? 3 ways, right? Because there were 3 ways, and out of that 3 ways, 1 is gone here, so 2 ways, my mistake earlier. So 2 ways. Now after this point is pretty straightforward. There were 7 numbers, out of them 2 are gone. So how many ways? 5 ways. And how many ways? 4 ways. And this is all multiplied, right? So once again, when you put 6 here, it only means one possibility, and putting a 6 here means for this first number you're only left with 2 possibilities, whereas earlier you were left with 3 because 5, 6 and 7. Or the other story is that the last number is going to be either 2 or 4, because we were talking about even numbers. So that being the case, how many ways? 2 ways. If that is taken care of, how many ways of filling up the first number? Now you can use the 6 here because it is not used there. So 3 ways. Out of 7 numbers, 2 numbers are gone. How many are we left with? 5 ways, and then again 4 ways. So 2 into 5 into 4, 40, plus 3 into 5, 15 into 4, 60 into 2, 120. So 120 plus 40 should be your answer. Option B, right? So this is question number 3, and again using the OR to resolve a difficult situation. Question number 4. Using the digits 0, 1, 2, 3, 4 and 5, how many 5-digit numbers having distinct digits? Distinct digit means you cannot repeat a number in your number, right? How many 5-digit numbers? So place 5 positions for yourself. How many 5-digit numbers can be formed which are divisible by 3, right? So divisibility rule of 3, you should remember that divisibility rule of 3 is sum of the digits should be divisible by 3. Right, now do a preliminary analysis, right? So you have 1, 2, 3, 4, 5, 6 digits, but you have only 5 possibilities, 5 ways of putting them here, right? So out of these 6 digits, you know one of them is not going to be considered. So let's try that out quickly. If I don't consider the 5, so whatever number will be made up of this, like 1, 2, 0, 3, 4, 1, 3, 0, 2, 4, lots of numbers will be formed. But the sum will always be the same, 4 plus 3, 7 plus 2, 9 plus 1, 10, right? Any number that you form, right, 1, 2, 0, 4, 3, 2, 0, 1, 4, 3, for all of them, the sum of the digits would still be the same, 4 plus 3, 7 plus 2, and 9, 10. And 10 is not divisible by 3. So any number that you form using this set of digits will not be divisible by 3, right? So that means this was useless. Try and remove 4 now. 5, 3, 8, 2, 10, 1, 11, not going to work. Try and remove 3 now. 5, 4, 9, 2, 11, 1, 12. This is going to work, right? So write it down for yourself. If you make numbers out of 0, 1, 2, 4, 5, it will work for you, right? Why? You had eliminated 3. Now try eliminating 2. 5, 4, 9, 3, 12, 1, 13. Not going to work. Try eliminating 1, 5, 4, 9, 3, 12 to 14. Not going to work. Try eliminating 0, 5, 4, 9, 3, 12 to 14, 1, 15. Going to work. So this is one possibility. Or 1, 2, 3, 4, 5, right? So that means out of these numbers, eliminate 3 or eliminate 0, and then this works for you, right? But as of now, you're not solved it, you're just looking at what digits will work for you. Now, if you consider this scenario, how many ways of forming 5-digit numbers? For the first number, you cannot use a 0. So how many ways? You had 1, 2, 3, 4, 5 ways. Out of that 5 ways, 1 is gone. 4 ways, right? For the second number, how many ways? You had 5 numbers, one of them is gone, 4 ways, right? For the third number, you had 5 numbers, 2 of them are gone, 3 ways, 2 ways, and 1 way. So how many ways for this? 16 into 2, 32, into 3, 96 ways for this situation, right? Using these digits, that's why that comma to separate them. And for this way, right? For this possibility, how many ways of filling up the first position? 5 possibilities, because I can use all of them. How many ways for the second possibility? 4, 3, 2, 1, because as you use up a number, your possibilities go down. So 20 into 3, 60 into 2, 120, right? So your answer would be 120 plus 96, right? 120 plus 96 should be 216, which is option B. So this is question number 4, and divisibility rule of 3 is being thrown around. Think I had to first consider what digits to use. Again, we're not using any permutation formula, maybe using that form. I mean, there could be many ways of doing this, but we're just talking of systematic thinking, step by step, according to the conditions given, right? So question number 4. Question number 5. How many 4-digit natural numbers have at least one digit repeated? So first of all, 4-digit natural numbers, and what will they be made up of? They will be made up of digits which are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? And it says at least one digit should repeat. What do I know? What methods do I know? I know all repetition, all kinds of repetition is allowed, right? And I know no repetition, right? And if I just look at these two and I do this, all repetition, that means all possible numbers, right? And this all includes non-repetition also. So from all, if I subtract non-repetition numbers, whatever numbers I am left with have at least one digit repeating, because they will be in the repeating category, one or more, that's what at least means, right? So this is the idea behind it, that at least one digit numbers, numbers with at least one digit repeating can be found. How? By finding the total possible numbers and subtracting non-repeating numbers from them, right? So let me find out the total possible numbers for 4-digit number, and for the first number I will have how many possibilities? I will have 9 possibilities. Why? Because out of 10 I cannot use a 0. If I use a 0, this will become a 3-digit number. For the second number, I have 10 possibilities, right? Because I can use the number, whatever number I have used. Let's say if I put a 5 here, I can put another 5 here, because I am counting repetitions also right now. And again 10 and again 10, right? So this would be all possible numbers. And remember, all possible numbers out of this contains repeating numbers, those numbers which have repeating digits, as well as those numbers which have no repetition, right? And I can individually find no repetition scenario. Say if repetition was not allowed, in that case what would happen? And you have again 4-digit natural number. So once again, for the first position, you cannot use a 0, so 9 possibilities, right? Now how many numbers did you have? 10. Out of that 10, 1 is gone, right? So how many possibilities? 9 again, right? And now you had 9 numbers, out of that another is gone. How many possibilities? 8. And how many possibilities? 7, right? So 9 into 10 into 10 is 9,000. whatever is 9 into 9 into 8 into 7, find that out, subtract from 9000 and you should get your answer, right? So question number 5, and the learning here is how to find at least one. Take the total and subtract the none and you will get at least one. Again, this is an idea that we've also seen in set theory kind of questions, right? So that would be the principal lesson involved here. So question number 5. Question number 6. How many 3-digit odd numbers can be formed? So you're thinking of 3-digit numbers and it should be odd from using the digits 1, 2, 3, 4, 5, right? So if the number has to be odd, the last digit should be odd. That means the last digit can be 1, 3 or 5, right? So how many ways? 3 ways. If this were the only question. But there are more conditions there. Such that 3 appears exactly once in the number. Repetition of digits is allowed. So 3 should come only once. The other numbers can be repeated, right? So let's stick with this and try out and see if there is an error involved. If I say 3 possible ways, okay, so for this number, how many ways? I cannot use a 3, right? So if this is a 3, I will not be able to use a 3 here and I will be left with 1, 2, 3, 4 ways, right? But if it is not a 3, if it is 1 or 5, then I can use 1, 2, 3, 4, 5 here, right? So I'll be left with 5 ways. So that is one thing. So how do I resolve this situation? Again, create a OR scenario for yourself, right? And let me start. Let me put 3 in the last place, right? So how many ways? 1 ways. If 3 is put here, it cannot be put here. How many possibilities? 1, 2, 3, 4, 5. Out of that, 3 cannot be taken. So 1, 2, 3, 4 ways, right? 4 ways. And for this second number, again, I can repeat all the numbers. So how many ways? 4 ways, right? So now, if I have done that, I can actually now go even slowly and say, okay, what will happen if 3 is in these positions? So if 3 is in the middle position, which is fine. For the last position, how many ways do I have? I can put a 1 or a 5 because I want an odd number. So 2 ways, right? And for the first position, out of these numbers, 3 is gone. 3 I can't use, right? But whatever number I have used here, I can use here again. So 1, 2, 3, 4. How many ways? 4 ways, right? Once again, the same thing here. In the end, I can have a 1 or a 5. So how many ways? 2 ways. This is already gone 1 way. And I know out of these numbers, I cannot use a 3 because I have already used it up. How many options am I left with? 4. So my answer would be 4 into 4, 16, plus 4 into 2, 8, plus 4 into 2, 8, right? So 16 plus 8, 24 plus 8 is equal to 32. Once again, for each question, you might have, you might straight away apply a formula and do it, or there might be other ways of doing it. Please submit them in the comment section. Alternate methods are always welcome, right? But what we're trying to do here is, while doing these questions, also revise the core ideas, right? Or also focusing on how to look at this problem and what is the possible error here, right? And we resolved it using the or. Perhaps you can save a few steps. So this is question number 6 and the answer should be option C, which is 32. Question number 7. What is the sum of all 4-digit numbers that can be formed using 1, 2, 3, 4? So 1 and 2 and 3 and 4 is what is given to me. And using exactly once, that means first of all, no repetition. How many numbers can you form? First of all, you will have 4 possibilities and then 3 and then 2, right? And then 1. So 4 into 3 into 2 into 1 gives you 24 ways. That means there will be 24 numbers first of all. And what is the question asking you to do? Question is saying all of these different numbers, for example, 1, 2, 3, 4, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, 1, 4, 3, 2, right? All of these numbers, all of them, just add them up and find the sum, right? Obviously, I am not going to find all of these numbers and write them together and find the sum. So there has to be some logic involved, some insight which can reduce my work, right? And that should be almost visible to you. So if I look at 1 for example, and 1 in the in the leftmost position, right? So if I look at 1, 2, 3, 4, 1, 3, 2, 4, actually 1, 2, 4, 3 also I missed. 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, 1, 4, 3. Can you think of anything else starting with 1? So how many numbers were there? 1, 2, 3, 4, 5, 6, right? So there were, if you think of 1 on the first position, there were 6 such numbers. If you think of 1 at the second position, again you will get 6 numbers, right? If you think of 1 at the third position, again you will get 6 numbers, and at the unit position again you will get 6 numbers. Overall you will get 24 numbers, right? And where am I heading with this? So if I say for example 1, 2, 3, 4, where 1 is in the leftmost position or at the thousands position, or if I go for 2, 1, 3, 4, or 2, 3, 1, 4, or 2, 3, 4, 1, right? I'm just focused on this 1's place, right? So if I look at what is this 1 going to add because of being here, in this case it is 2341. So this 1 only means a value of 1 addition. If I look at 1 at the tens place, this is 2314. So this 1 is actually adding a 10. If I look at this one, it is adding a 100. If I look at this one, it is adding 1000, right? So at 1 being at 4 different positions, this is what it is adding. And what is the sum of this? The sum of this is 1, 1, 1, 1, right? But this is not the case. What else do you know? You know that for the first position, if I lock down 1, that means only one way, right? Let's say for 4 digits, if I lock down 1, how many ways? One way. And then it would be left with 3 ways into 2 ways, right? So if the 1 is fixed here, there are 6 ways of doing that, right? So for this there would be 6 numbers, for this there would be 6 numbers, for this there would be 6 numbers with 1 at the tens position, and for this also there would be 6 numbers, right? So this 1, 1, 1, 1 into 6 you should do, right? And why? Because this sum represented only 4 numbers and you have 24 numbers, right? So 6, right? What else is happening? You are only considering 1, the same story will also apply with 4 and 3 and 2 and 1, right? So this was, so for 1 it was 1, 1, 1, 1, 1, 1. For 2 it would be 2, 2, 2, 2. For 3 it would be 3, 3, 3. For 4 it would be 4, 4, 4, 4, right? So let's just keep 1, 1, 1, 1 there and just straight away add up. So 4 plus 3, 9, 4 plus 3, 7, plus 2, 9, plus 1, 10. So this, all of this into 10. So 10 into 1, 1, 1, 1 into 6 is your answer, whatever the value comes out as. And again, I have gone for what happens to the 1 story. You could have gone for what happens to all numbers, or any which way you want to use. The answer would remain the same. Again, point being, obviously you were not going to find individual numbers and add them. There was a way of analyzing them. And the new thing that you can learn or revise once again is that what does this 1 bring, right? When it is at the units position, it brings only 1. At tens position, it brings only 10. You can also think of 4, right? Say 4, 3, 2, 1, 1, 4, 2, 3. I'm writing random numbers, only changing the position of 4, right? 1, 2, 4, 3, and let's say 3, 2, 1, 4. So in this number 3, 2, 1, 4, what does this 4 represent? Only 4. In this number it represents 40, in this number this represents 400, and in this number it represents 4000. And if I take the 4 common, I'll be left with this 1, 1, 1, 1 only. So that's why I just look at this, multiply it by 6 because for each situation there are 6 numbers, multiply it by 10 because of this, right? Or do 1 into 1, 1, 1, 1 into 6, plus 2 into 1, 1, 1, 1 into 6, right? And plus 3 into 1, 1 into 6, etc, etc, etc. So you will get your answer as whatever you will get your answer after you find that out. If you have an alternate method or a solution, please do submit in the comment section. Other people can learn from it, I can learn from it, right? So this is question number 7, and this being the thing worth learning from this question, right? Question number 8. 3 couples and 1 child of each of the 3 couples. So couple, child, couple, child, couple, child, right? How many people? 9 people. They have to be seated in a row. So draw the positions 3, 3 and 3, right? 9 positions. Quickly revise the idea of seating people in a row. So say there are 3 people and you want to seat them in a row. Very, very easy. For the first position you have 3 possibilities, A or B or C, right? For the second you will have only 2 possibilities because one of them will be gone in the first seat. And for the last you will have only 1 possibility, right? If there were 5 people, again, unlike the numbers, there can't be a possibility of repetition here allowed at all because you can't clone people, right? So there is no question of repetition. But if there were 5 people, so for the first position there were 5 possibilities, for the second there were 4, and for the third there are 3, right? So this is the basic concept behind arranging people in a row. At this point you can also start using the formula, but again let's avoid it for a minute. And the story says, seat them in such a way that the child is sitting between the parents, right? So the child should be between the parents. So that means, can I put a child here? I cannot put a child here because there is no position for the parent, because the parent should be on either side of the child, right? So where can I put a child? I can put a child in this position because I can put the parents here. Can I put a child in this position? Because this parent would become different, right? And the child should be between its parents. So again, this and this. After a little bit of thinking, I hope you come to the same conclusion that these are the possible seating positions for children, right? Okay, how many ways can I do it? I can do it again 3 ways. If I take one of the child and put them here, how many ways can I do this? 2 ways. And how many ways can I do this? 1 way. So how many ways for the children to sit? For children to sit there are 3 into 6, 3 into 2, 6 ways, right? Right? And now I have to seat the parents, right? So how many ways for that? If I think of this child, how many ways? 2 ways. Mom here, pop here, or pop here, or mom here, right? So 6 into 2. And you also have to worry about these 2 parents. Again, mom here, mom 2 here, pop 2 here, pop 2 here, mom 2 here, whatever, 2 ways. And the same situation for the last thing, 2 ways. So 6 into 2 into 2 into 2, or 6 into 8, your answer should be 48, right? So step by step again, first basics of arranging people in a row should be clear. And then I understood that these are the 3 positions for children. These 3 positions, forget the extra position, just focus on these 3 positions. You can fill in 6 ways. Once you have done that, you know you can have a possibility of mom pop, pop mom, and the same thing and the same thing, and all of them ANDed together, right? Why? Because you can have a mom pop and a mom pop, which would be 1 way. You can have a mom pop and a pop mom, mom pop 1, and pop 2 and mom 2, which would be another way, right? So therefore they are getting multiplied with each other, and your overall answer would become 48. So for question number 8, your answer should be D. Question number 9. 7 individuals have purchased 7 tickets for consecutive seats to watch a match. So 7 positions, 3, 4, 5, 6, 7, right? Then it says 2 individuals want to sit together, right? So they want to sit together, and not only that, at only the end of the row, right? So they want either these 2 seats or these 2 seats, right? So first of all, whatever there are 2 people, let's call them A and B, right? So they can be A and B in this position, or B and A, right? So 2 ways of doing this. And overall, how many ways I can see? 1 way or another way of that. So 2 ways of doing that. So 2 into 2 so far. So these 2 people are now have covered. There are 2 possible stories. These 2 seats or those 2 seats, right? And then it says 2 individuals are adamant about sitting in the middle 2 seats. So again think of A and B, and they are now focused on these 3 seats. And how do I go for that? I know seats are more, so let me look at the people. A has how many options? He has 3 options. B has how many options? He can choose from any of the 2 seats, right? So this also just multiply into the story, right? So now for both the stories, Out of these 3 seats, 2 are gone. Which 2 I don't know, but 2 of them have been taken by those 2 people, and I have accounted for it by using this expression. So how many people are gone? 4 people are gone. Now how many people are you left with? You're left with 3 people, and you have 3 remaining seats. In this scenario, you will have 2 seats here and 1 of these, and in this scenario, you will have 2 seats here and 1 of these. But overall, there are 3 seats remaining for 3 people, and that is as simple as 3 into 2 into 1. Multiply this, 4 into 3, 12. 12 2s are 24. 24 2s are 48, and 48 into 3 is 144, right? So your answer for question number 9 should be option D, 144, right? Question number 10. There are 4 red balls numbered 1, 2, 3, 4. That means R1, R2, R3, R4. They become like people or characters, right? And there are 3 blue balls numbered 1, 2, 3, B1, B2, B3, and 2 yellow balls, yellow 1 and yellow 2, right? So 4 red balls, 3 blue balls and 2 yellow balls, right? And the question says the blue balls should not be together. This is very much like the basic question that we have learned, that no 2 boys can sit together. There were boys and girls in the story, and you had to separate the boys from the girls. And in that case, what you did was you first arranged the girls, and then the spaces were created. So forget about these 3 people for a minute. And how many people are left with? These are people only. How many people? There are 6 people. How many ways can I arrange 6 people? The answer would be 6 factorial, right? 1, 2, 3, 4, 5, 6 positions. First person can have, the first seat can have 6 possibilities. The second have 5 possibilities. 4, 3, 2 into 1. So all of this put together becomes 6 factorial. For this question, I'm assuming some exposure to basics, right? Sorry. So this is 6 factorial, and you have already arranged these people, right? And what happens once you arrange 6 people? So if you say 1, 2, 3, 4, 5, 6, what you get is 1, 2, 3, 4, 5, 6, 7 positions, right? So now it becomes a very, very simple question. You have 3 people and you have 7 positions. How can you fill them? Very, very simply, for the first time I'll use the formula. It is going to be 7p3, right? So my answer is going to be 6 factorial into 7p3, right? And 7p3 means what? Out of 7, choose and arrange 3. And that's what I had to do. 3 people had to go into 7 sitting positions. So 7p3 is my answer. And what is the meaning of this? For that, try out the basics video, most definitely, right? So now onwards, maybe we'll start using the question, right? So for this is it for part 1. See you soon. In part 2, we'll try out the rest of the questions. Before that, maybe it's a good idea to quickly revise the basics videos. This time, if you have already done it, you can try them at 1.5 speed or 1.75 times the speed and see what happens, right? So see you soon.